I'm making a turn-based RPG with perfect information availability, no randomness, no grinding, and a story about trauma that is deeply personal to me. I talked about my plans and motivation in more detail in the first episode, so I won't repeat myself here. This is episode 3. First order of business was to refactor how my state machine works. Then I wasn't happy with the refactor, so I refactored it again. Then I refactored the mod system, so every single thing I showed in the last episode no longer applies. I actually wrote a whole explanation of exactly how I changed it and how it works now, but then I realized that everyone either already knows or doesn't care. Probably. For those who do care, it went from a switch statement to a set of singletons that implement an interface to a set of instances of a class that use delegates in place of override. Babe, wake up, it's regular expression time. Next, I made a stage and actor system. Everything that you can see is an actor that has been added to the stage, and they have a bunch of data like position, alignment, priority, size, etc. This basically just makes it easier to manage what I'm drawing. The way I had made the menus in the previous version of the game was as simplistic as possible. For each menu, I just create all the visual objects and check inputs. However, this was slow and error-prone. It wouldn't hold for more complicated menus. So I needed to create a UI framework. Well, I could have used a pre-existing one, but come on, this is me we're talking about. Each menu consists of actors and widgets. It adds the actors to the stage and controls the layout and input of the widget. Each widget has a preferred control scheme. For example, tab bar widgets, being horizontal, prefer to be navigated with the left and right keys. However, if another widget from the current layout takes left and right, it'll fall back to using the page left and page right keys, the shoulder buttons on controller. The first widget I wrote was list widget, which is simply a vertical series of labels. The brightly colored boxes are a debug view. Magenta is the size and cyan is the padding. As you can see, the cursor isn't in the correct place, and the left and right padding is ignored entirely. Here it is after some fixes. This is still missing a lot of functionality, but at least it actually looks correct now. The code for all of this UI stuff can be very difficult to read just because of how many factors are involved. And here's tab bar widget working. Previously, the queue and the inspect menu's unit list were separate. However, they're both showing the same thing, so why not make the same display handle both? I thought this would be easy to do, but getting the ordering to play nice and not get messed up even when you open the menu at a weird time was torture. In the old version of the game, HP and SP were bars, but the other stats were just numbers. This time, why not make them all bars? I'm also making all UI elements bigger in general to improve readability. I added an animation for when the inspect menu is opened and closed. Now, everything slides in and out of place. I've received several complaints that my color scheme is bad. Naturally, the only reasonable thing to do was add hot swappable themes. This one is High Contrast, Apollo, Void. This is actually my custom VS Code theme. It looks a lot better in code than in game, though. VS Code, this is just the default VS Code theme. Miku Miku theme. And Red Mode. This one will probably be the default, as it's the most well-rounded. There are even entire game consoles that can only display these colors. Joking aside, I'm still not sure what the default theme will be. The next thing I did was make a registry, which assigns everything in the game, skills, themes, stats, etc., a unique string that can be used to find them. For example, in order to refer to the Fireball skill from the mod Celosia, it's as simple as searching the registry for Celosia skill Fireball. This is very useful for cross-mod communication, as well as for serialization, which is the process of converting data to a text format that can be read back, such as save files. Next, I redid my Lang system to work much the same way as the registry. Previously, I used the built-in Resource Manager system, where you write an XML file and embed it directly inside the final DLL. It's very buggy, janky, and inextensible. I wrote my own system with a single central registry for each language. For example, in order to refer to the English name of the Fireball skill from the mod Celosia, I searched the English registry for Celosia skill Fireball. This system change also gave me an opportunity to use a different data file format that isn't XML. I decided to go back to what I had before I rewrote the entire game and use a .properties file. It's as simple as can be, essentially just being a list of key value pairs. .properties is generally exclusive to Java. Fun fact, it's what Minecraft lang files use. So as far as I know, there is no existing .properties parser for C#, but the format is so simple that I could write one myself easily. All you need to do is go through each line, check if it's a comment, and if it's not, split it by the equals sign and add each part to a dictionary. I didn't implement the entire format though. For example, in the official properties parser, the delimiter separating the key and value can be an equals sign, a colon, or any white space. My parser only accepts an equals sign because that's the only one anyone actually uses anyway. I added a performance graph that measures the time spent on drawing and updating each frame. Having the graph open increases the draw time by quite a bit, but as you can see, on my pretty old PC, it ranges from less than a millisecond per frame to about 2 milliseconds per frame when I open every possible debug menu. For context, in order to hit 60 FPS, you need 16 or less milliseconds per frame. I get about 500 to 1800 FPS, depending on what I'm currently doing. I have too many debug hotkeys, so I started adding a debug console where you type commands. It currently doesn't evaluate the commands, and the text input has a ways to go, but as you can see, when it's focused, it captures inputs so they don't interfere with the game below, and focus can be freely toggled by hitting escape. I've been spending a lot of time on stuff that's very hard to talk about in this sort of video, such as making a UI framework in order to better recreate menus that I've described before. Due to this, I had a hard time finding things to talk about that weren't too technical, hence this video's shorter duration. Thank you for watching. Join me next time when I rewrite everything because I've decided that I'm too good to use built-in language features. Here's how I write if-else snap.